All right, let's take a look at your assignment here on continuing to practice the conditional probability and then looking at the concept of independence, okay, and how to check for that. So, here right at the beginning, what you'll find is that, again, remember that we knew when we were checking for independence, we had to check to see if the probability of A equaled the probability of A given that B has happened. Okay, so that's the general gist of what we need to check every time. So here, probability A is given to us. So then we just need to check that probability of A given B. And then, of course, we know that that B is on the bottom and the A and the B is on the top. Okay, those have to be within 1% of each other. 62.5% was not within 1% of 70%, so not independent. Because the fact that you were B in this case lowered that probability of the event A occurring. All right, here we had the overall probability of A is 0.45, and then A given B, there's the B, on top is the A and the B. And again, we see that the fact that B has happened lowered the probability of A, event A, happening. And then here was our next one here. We have our probability of A is 0.61. And again, here we see the fact that B has happened lowered the probability that event A is occurring. So those were all three not independent. Now here we had a problem. And when we read this, we see, of those who went to Whataburger, there was a 60% chance of being seniors. And of those who did not want to go to Whataburger, 30% was seniors. So that rate of seniors was conditional upon if the person they picked was going or not going to Whataburger. Okay? So I've always kind of thought this problem might be worded backwards. Would you say? Well, anyway, we'll keep going on that. I won't get lost in that. So because of that multiple conditional probabilities, then I say to myself, oh, I'm going to diagram a tree. That's the strategy for me. So here we go. Let's see. So I put my Whataburger and not going to Whataburger, and then I did the conditional from both of those sections. Then the question that was asked is, if a randomly selected student at the football game is a senior, then what's the probability that this person wants to go to Whataburger? Okay, so what you have then is all the seniors on the bottom. So that's our Whataburger seniors plus the not Whataburger seniors. So that is then why there's those on the denominator. And then we want to see of those, what is the going to Whataburger senior portion? Do not put 36% on top. It's the going to Whataburger seniors, going to Whataburger and seniors, that's the 2.16 is what is on top. Okay, next. Then we said, are they independent events? Okay, so remember that as we had seen up above, then to do the checking for the independence, we're going to say, okay, probability of event A, does that equal the probability of A given B? Okay, those need to be equal to each other. So what happened was I was like, oh, you know what? I've already done part of this work in part A. So I know that answer right there. I got that from part A. So I'm going to say the event B is a senior and event A is going to Whataburger. Then all I have to do is write down Whataburger probability of 0.36. So 0.36 not equaling 0.53. So going to Whataburger and being a senior are not independent because the fact that you're a senior makes it more likely that you go to Whataburger. And, then you do statistical evidence, 53% for seniors, 36% overall for the marginal. Okay, moving on. So this was another one where we were told those who have flu, those who do not have flu. And so the rate at which you had temperature was affected by if you had the flu or not. Okay. If you had the flu, 90% had high temp. Okay. If you did not have the flu, only 12% have a high temp. So when this question says, if a randomly selected person has a high temp, what's the probability that they have the flu? Well, we can see here that this flu high temp plus the no flu high temp is the denominator, and the part of that, do not put 0.35 on top. It's not the total flu. This 35% is the flu people who had high temp and the no high temp. So that's all of them. We only want the high temp flu people. So that's that 0.315. So if you have high temperatures, 80% chance that you've got the flu. So we certainly could apply that to a lot of our statistics happening with our COVID investigations and checking your temperature before you come to school and so on. So here again, we have got you that what we notice is that you earning over $100,000, that rate is different based on if you're a Democrat or a Republican. So that's our conditional. We have two different conditional rates at which you earn over $100,000 in a year. So therefore, we make a tree diagram. So there it is. I got the Republicans and their rate at which they have those salaries, and the Democrats and the rate at which they have those salaries. So if one person who earns over $100,000, so that's the given. So see, given that they earn over $100,000, so I need to put all of the over $100,000 earners down here. So that's those 12% and those 0.0425%, 4.25%. So I put all those on the bottom, and what part of those are the Republican ones who earn over 100,000, not 15% on top. This overall Republicans is not what goes on top. It's the Republicans who earn over $100,000 that go on top. Okay? So, if you earn under $100,000, over almost 74% chance you're a Republican. Okay. Let's see, was there any other down there? Nope. Next. Again, the rate at which you drink coffee changed based on if you were a student, a teacher, or administrator. Okay? I can see that teachers teachers are drinking coffee at a much higher rate than everybody else, okay? Especially nowadays. All right? So, there we go. All right. So we've got our students. Here's the rates they drink and do not drink coffee. Our 9% are teachers, drinking and not drinking coffee, and our admin, drinking and not drinking coffee. So the question is this. Given that you randomly select a person and they are not drinking coffee, what's the probability they were a teacher? So I need to put all of the no coffee situations as my denominator. That I have circled. That's this 72%, this 0.018%, and this 0.04%. So that denominator is down there. And the part of that, it's not 0.09. No, it's the no coffee drinking teachers. It's this part, okay? It's that teacher portion of the denominator. All right. And let's see, if a randomly chosen person drinks coffee, then what's the probability here? She is a student. So then I had those different pieces to look at. In that case, I had to look at my drinking coffee. And my drinking coffee was the 0.18, the 0.072, and the 0.06, of which the part I'm interested in was the student part. So that student part was the right here, the 0.18 was the student part of that denominator. All right. Ooh, this is a good one here. Here we have got stuff happening where when we select something, the probability now changes. So let's take a look. I do tell you that. I gave you that hint to pay attention to that fact. So we have a dozen old batteries. Okay, so 12 batteries are in our junk drawer, and 5 are totally dead. All right. I don't know why they're in there. How do we know that 5 are totally dead? Anyway, you start picking batteries out one at a time to test them. When you pick a battery to check it, you do not replace it. Okay, so I did remind you of that fact. The original prompt did not have that fact in there. Okay, so I wanted to give you that hint so that you didn't just do this problem completely wrong. Because, especially when we have such a small sample, picking out one of those pieces and keeping it out affects that probability. The next one is a much different probability. So, the first two are good. That means I've got to have 7 out of the 12 are good. And the second one, 6 out of the 11 are good. Okay, so that's how we get that. Next, we've got our, let's see here. We've got our, at least one. The probability of at least one is 1 minus the probability that none of the first 3 batteries work. All right, so for none of those first 3 batteries to work, the first 3 batteries are bad. Okay, so we've got to go through that probability of 3 batteries being bad. So that's 1 minus. Here comes the bad battery after another bad battery after another bad battery. 5 out of 12. And then 4 left out of 11 in the box or in the drawer. And then 3 left out of the 10. So that's all 3 batteries are bad. So do 1 minus that, and that gives you the probability that at least one of the first 3 batteries works. What's the probability at least one of the first 3 batteries works? Pretty good chance. All right, the first 4 you pick all work. So that's 7 over 12, 6 out of 11, 5 out of 10, 4 out of 9. They're all working. So that's only a 7.1% chance. And then you have to pick 5 batteries to find one that works. So that is saying that by the 5th one, that 5th one you've gotten, that is the one that works. You had to pick 5 for that one that works. So 5 12s, 4 11. So these are the bad ones. Bad, bad, another bad, another bad. But then look good. There's 7 out of 8 of them that are left in there that are good. Okay, so that last time's pretty darn good. So in other words, we're probably going to be getting a good battery before that try because that's less than 1% chance. All right, now we have a table. So we're going to want to be careful on how we read our table of values. So what's the probability we select human ecology? There is that one. So we're picking out of all of the students, human ecology, out of all of those students. We select a firstborn. So that's out of all of them. Firstborns were 113 out of the 223. Now look here. This one is an intersection. The probability that a person is firstborn and human ecology. So out of the 223, firstborn and human ecology, there's that intersection of 15 out of 223. Now, what's the probability the person is firstborn or human ecology? Several ways you can do this, but make sure you put it out of the 223. So what did it say? Firstborn or human ecology. So that's 113 right here, plus these 43 right here. Well, if you added these 43 plus those 113, these 15 got counted twice. So I can add on the numerator 113 plus 43, subtract 15. Okay. Other way I could do this would be to add up all of these. And so I got my 113 plus these additional 28 right here. Okay? So because I know that 15 is already counted. So you could do that. All right? All right. A few ways to do those. E, if we select a student at random, okay, so again, that's out of all the students. So that's why my 223 is my denominator. What's the probability that person is an arts and science student who is a second child? So that's asking you for the intersection of arts and sciences and second. So 23 out of the 223. Uh, So that's not what I have there. So what's going on here? Arts and sciences student who is a second or more. So, I think I have it wrong on my answer key, right? Let me just double check here. If we select a student at random, so that's out of the 223, what's the probability that the person is the intersection of arts and sciences and second or more? When I put 57, I had just put all of the arts and sciences, so that was wrong. It should be this 23 out of 223. So I've got to fix that. I had that mistake right there. Okay. Now, here we have some conditional probability. Let's take a look and see if you caught that these were worded correctly. Among the arts and sciences students, that is given that you have the 57 arts and sciences students. So out of those 57, what proportion of them were the second child or more? And that's that 23, just like that 23 that we should have had up there on E. All right, next, among the second children or more, what's the probability that they were? So among the second children. So that's given that they are one of the 110 second children or more. What portion of those are the arts and sciences? So see, here we go. Given that they are part of these 110 right here, what part of those are the arts and sciences? So the 23 out of the 110. What about this? What is the probability that a first or only child is enrolled in the agriculture college? So that's not saying a randomly selected student who is first child and agriculture. That is not saying the first, let's see, the 52 out of the 223. No, that's saying out of all the 113 firstborns. So that's the fact I'm telling you first and foremost. And of those 113 who were the agriculture students, there you go, right there. Okay? So next, what's the probability that an agriculture student, so that's out of the agriculture students, there's 93 of them. What proportion of those were the first or only those 52? Okay, hopefully you felt confident about those, and we'll just continue to practice that for one more day before we have our quiz over conditional probability and independence.